Hello students, welcome back. Let us take a look at the summary of chapter 12, Heron's formula. Very short summary that you must have seen so far. So here we learnt about two major concepts. One was area of triangle and finding the area of quadrilaterals. So how was it different compared to the normal formulas that we used earlier for finding the area of triangle and quadrilaterals? So first of all, in general, the area of triangle, it's very simple to find using the formula half into base into height. In cases of equilateral triangle, isosceles triangle and right angle triangles. Why do I say this? Let's say I have a right angled triangle, then I have the base and I've been given the base and height, I can find the area of my triangle. If I have an equilateral triangle, in equilateral triangle we know that the altitude, that is the perpendicular drawn from one vertex, and the midpoint, the median, they coincide. So this segment, line segment out here for my equilateral triangle is also the perpendicular height as well as the median. If I've been given this length and any one side, obviously all the three sides are equal. So if I have any one side, because all three sides are equal, I will have this side as the hypotenuse, this side as half of this entire length. I can find this length using Pythagoras theorem. Then I can find the area of triangle using half base into height. Similarly, if I have an isosceles triangle, so these two sides are equal, I've been given one of the congruent side and this base. Again, I can draw a perpendicular out here. We know that in an isosceles triangle, this perpendicular is also the median. Therefore, we can find the height and we already have the base, so we can find the area of your isosceles triangle. But in cases of scalene triangles, it's not really possible to draw a perpendicular and find the height of it. Although we can draw the perpendicular, there is no relation to find the height. In these cases, we use the Heron's formula. So for Heron's formula, we need the three sides and the semi-perimeter of the triangle. So semi-perimeter would be what? If I have my triangle ABC, and if I walk the path from A to B, B to C, so if I go from A to B, B to C and C to A back again, the distance covered is the perimeter. So this entire length A, B, C, A is the perimeter. So semi-perimeter is half this length. So we need the semi-perimeter, which is going to be A plus B plus C divided by 2. So what is lowercase a? The side opposite vertex A is this A, this side is B and this side is C, because A, C and B. And Heron's formula is given by area of triangle ABC, or any triangle if it would have been, let's say DEF, so you would just replace ABC by DEF respectively. It is given by under root of S into S minus A into S minus B into S minus C. And also the unit of area is always square units or unit square. So if you get your answer of areas like 3, so it would be either 3 square centimeters or 3 centimeters square. It could be meters, it could be kilometers, it could be miles, but square is very important. So square here and square here is very important. Then finding the areas of quadrilaterals. What we did is, in order to find area of quadrilaterals, we split the quadrilateral into multiple triangles to find its area. So for example, if I have a rhombus ABCD and any one side and the length of one diagonal is given. So first of all, we know that for this rhombus, this is just an example that I am giving you. We've been given one side, let's say 3 centimeters, and let's say one diagonal length is given as 5. We can obviously find the area of any of these triangles. Why? Because each of this is 3. So I can find the area of triangle BCD. Now we know that in a rhombus, the diagonal divides the rhombus into two triangles of equal area. Therefore, area of triangle ABD is equal to area of triangle CDB. We already would have found the area of triangle CDB. Therefore, the area of triangle ABD would be the same. So this was just in the case of rhombus. For quadrilaterals, we similarly divide the quadrilateral into different parts. For example, the last question that we learned, we were given a trapezium it was something like this, wherein these two sides were parallel and these were non-parallel. So what we did is that we constructed a parallel over here. This was AB, CD. We constructed BE parallel to AD. So now we had the parallelogram and we had the triangle. We were given this side, this entire side, this side and this side. So if I remember correctly, this was 10, this was 25, this entire length was 25, this length was 13 and this length was 14, all meters. So when I drew this parallel to this and this parallel to this, ABED turned out to be a parallelogram. Now this was a parallelogram, therefore opposite sides are equal, therefore this length was 13 and this length DE was 10. Therefore this length was 25 minus 10, which is 15. So for this triangle BEC, I have my area using Heron's formula. Using the area, I am going to find the height of this triangle. Now I have the height. This parallelogram and this triangle, they lie between common parallels, therefore they will have equal heights. We have learnt this earlier in the previous chapters. Therefore area of parallelogram is base into height. We have the base DE to be 10 and the height, whatever height that we got, and we get the area of parallelogram. We add the areas of this parallelogram and this triangle and we get the area of the quadrilateral. So even if you see over here, if you are given an irregular shape in the form of a quadrilateral, we can split it into parallelograms and triangles and then apply Heron's formula, or even if you have something similar to half into base into height, it's not important that you use Heron's formula all the time, you would just have to pick up the right one. So this was about the summary of chapter 12, Heron's formula. Please take a look. So I hope you enjoyed this chapter. Let's see each other in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.